Hello, this is the first of a series of videos for an extra review for Thursday's quarterly exam. It's broken down by topic on the 5 questions you'll see. The first of which is exponential growth and decay. This topic is going to be very similar, or you guys should have a lot of experience from your third quarter project where you did modeling for those cars that you looked up. In that case, you're mostly focusing on the decay portion of it as the car prices went down, but obviously we also have growth considerations to take into account. So a little review here on the basics, and then we'll take a look at the problem down below in a second. So some of the basics, the formula itself, or the model, the exponential model that we use with these problems, looks like this. Okay, the plus minus is referring to whether it's a growth, then we'd be adding the rate, plus R. And the minus, if it's some type of decay, like your car project, I would say a good majority of you chose cars that went down in value. Obviously, they got older, they lose value. We would be minusing the rate there. Problems where we talk about money and savings accounts, obviously we're adding rates. Otherwise, we have to look for kind of like vocabulary to tell us, hey, should we be adding or should we be subtracting? So that's the first thing to take into consideration. The other things, what are these different pieces? Okay, P represents your principal, basically what you started with, starting value. Okay, if you invested or you deposited this, that's your starting value. If you bought a car that was originally $20,000, that's what you started with. The left-hand side, that A value, is going to be your final value or your new value after a certain amount of time has passed. The R is your rate. The thing with rate, we're giving it as a percent. So when we say something like 2%, that doesn't mean we're going to do 1 plus 2. 2% is actually representing 200, so we want to make sure to convert all percents to, trying to think of the phrasing, I guess we'll call them decimals. A regular number, basically, right? We don't want to just take, hey, it says 1.5%, I'm going to plug in a 1.5. If it's 1.5%, that's really going to look like, remember 2 spaces to the left, 0.015. That's what 1.5% actually represents, right? We're really dividing it by 100. And the last piece, the T up top, is representing time. That's your exponent. That's not multiplied. Notice I wrote it in the top right corner there. Time, or T, is representing years. How long have you deposited? How long have you owned that car for? Okay, so with that formula in mind, let's take a look at this example problem. If you want to try it on your own first, obviously feel free to pause it and try it and kind of hit play as you please here to see the answers. So it says the value of Apple stock has been increasing by 6% since the beginning of 2015. It began that year with a price of $57. So it asked me to first create a function and then basically apply it. So the first thing, I'm going to do some behind the scenes work here. 6% I see. I want to write that as 0.06 right away. Again, that's 2 decimals over to the left when we convert a number or a percent into a regular decimal number. Also, is this growth or decay? It says the word increasing. So we're going to assume that's growth. So we're going to be doing 1 plus R when we write our function. Some of the other information here, we see it started. It says the word began with $57. So this is going to be my P value. So when I write this function, A of X is going to represent the value. Okay. My initial or starting value is 57. In the parentheses, we're going to be doing 1 plus R. So 1 plus 0.06. And my exponent here is just X. That's representing, even says here, X years. Okay, obviously this is going to change if we're talking about 5 years, 10 years, 20 years. So X is kind of the variable. I can take this one step further and simply add it, or if it was a decay problem, I could subtract it. Actually doing the math, either of these is acceptable. And each of these would represent or model this value after X years. Okay, and now applying it, it says find the estimated value, because we are kind of guessing in so many ways, right? This is called extrapolating. We're predicting. We don't know what it's actually going to be in 2019, but we can predict. In 2019, so there is a little trick here. We don't just want to look at this and say, all right, I see 2019, let me let x equal 2019. For obvious reasons. We're not starting in the year 0. 2019 years haven't passed. If you look closely back at the problem, this scenario started in 2015. So if we want to find the value in 2019, how many years are we looking at? Okay, you could probably do the math without a calculator. 4 years. So I'm just going to simply evaluate a of 4, or plug in a 4 for x. This you would require a graphing calculator. I would recommend typing in 57 parentheses 1.06. Close the parentheses, make sure to hit the caret for an exponent. And we'll write down what we get. So plugging it in, I get about 71.9611 ... going on forever. A lot of these problems deal with either population or money in this case. So with money, I can have decimal places, specifically 2. And sometimes it will even explicitly say, like, round to the nearest cent. If it doesn't say, it's not a bad idea to round to the nearest cent anyway. It's kind of assumed with money that we use 2 decimal places, unless otherwise stated. Sometimes it might say nearest dollar. But in this case, let's round to the nearest penny. So it's going to be $71.96. So that's our prediction of what it will look like in 2019 based on what it's done so far. Okay, this is an exponential growth / decay problem. Just a quick little recap. Knowing your basic formula up top we discussed, knowing how to set things up, labeling. Tricks involve usually the percentage. So make sure you convert your percent to a decimal correctly, 2 spaces to the left. Make sure you plug into the model appropriately. Be careful if you're adding for growth or subtracting from 1 for decay. And then when you evaluate, make sure you use the graphing calculator appropriately. Make sure to hit the caret for the exponent. Also, it's a good idea just to type it in as a whole. Don't try to break it up into pieces on your calculator. Okay? Thank you guys for watching, and if you have any questions, be sure to let me know.